I'm Patty.
And I'm Tracy.
And welcome to another episode of Science Exposed. This week we're going to do some experiments that we have been asked to do, some experiments that wow. So as you can see, we're outside. I would advise that all of the experiments we're doing today be done with an adult under supervision, and make sure you make all those necessary safety precautions. We have fire extinguishers, goggles, everything we need should, an accident happen. And with science, everybody knows it doesn't always go 100% perfect. So be prepared. So let's get our goggles. I think the first one, it's been kind of going viral right now, according to the children at school. They're saying charcoal snake's pretty cool. So I thought, well, we need to make this. So put my goggles on. So we have a pan of sand right here. And what we're going to do, and we've put it in a heat-proof container. You could use a bowl, a cookie sheet. I had an empty pie tin in the storage, so we're using that today. So what we need to do is we need something to burn in here to make a charcoal snake. So you're going to take 1 part baking soda to 4 parts of sugar, and you can just mix that in the beaker here.
Okay.
So however big you want to make it, we're just probably going to use about a tablespoon of each.
Okay.
I would say that's big enough for this container.
So that's 1 part there.
1 part there. And again, you're going to find perhaps different recipes online, but we found that when we were doing this experiment that this worked best for us under our conditions.
3. So 1 part and then 3 parts? Or
4 parts.
4 parts. Okay.
And then just give that a little stir up. You can just use the spoon you have there.
Okay.
Now, I like to make just indents. Just use the back of your spoon, maybe a couple around the middle of your sand here.
Like that?
Sure.
Another one?
Yeah. It's a little breezy out, so we're gonna, make 3 or 4. Somewhere to hold it in, because the sugar's quite powdery and the baking soda. Perfect.
Okay. Yeah?
Excellent. Now we'll just go ahead and pour some of that into each of the little indents. As you can see, it's blowing already.
Okay. Here we go. And I'm just gonna use it all, hey?
Yes, for sure. Now you have to be patient. This experiment does take time because you're burning something. You have to wait for that chemical reaction. You have combustion happening. You're going to see, and we'll explain that in a minute once it gets going here. It does get hot, so I think it'd be best if we move this to the ground to get that going. So just pick up your tin with everything in it and move it to a safe location on the ground, and then we're going to light the sugar up.
Here we go. It's a little bit windy.
It's a little windy today. There we go. You
You
can
got
see the flame is going there. So in this you have 3 reactions happening. The sugar is going to combust or burn in the presence of oxygen. As you know, we have oxygen in the air.
Thankfully.
And then you get carbon dioxide and water vapor, which water vapor is also a gas, for those of you that didn't know that. And then this pushes that baking soda sugar mixture up, and as you can see, it's starting to grow. Now, this sugar also is undergoing a thermal reaction, decomposing, because it's producing solid carbon and water vapor. And that solid carbon is giving those little snakes their shape there. It's making them black, just like when you roast a marshmallow on the fire in the summertime. You see, if you hold it too close, it starts on fire and burns black like that.
That's the best marshmallow.
I know. So welcome back. We have another fan favorite experiment, I'm going to call it. This is Diet Coke Mentos, but I'm mixing it up a little bit. I want to see what type of pop actually works better. So I've bought 3 different varieties. I have a Diet Pepsi, a Diet Coke, and just the store brand Diet Cola. So you need all of 2 liters I find work the best with a whole package of Mentos. And what I have here is just, it's a little test tube, it's a plastic test tube. I like to open the Mentos and put it in the test tube. It causes me to be less sticky when I actually perform the experiment. So I just like to open them up and
Do you want me to
fill it
do
up.
this too with this one?
Yes, please. We'll do 3 because we have 3 different bottles we're going to test. So any predictions as to what you think might happen in the experiment? Which type of pop is going to work better? Or I guess maybe not necessarily work better, but have a higher explosion?
Well, I always hear that it's Diet Coke and Mentos, so I'm gonna guess that.
Diet Coke, okay.
But I remember a kid did it at a science fair, and he did like Mountain Dew or something.
Oh. So you could try that at home. You could try like orange soda, Mountain Dew, maybe Sprite. Maybe, do you think the color might have an effect on it? You could test that as an experiment. Here we're testing, you know, we're trying to keep as much constant as possible. We've used Diet Cola in all these experiments. And I like to use a Diet Cola because I find it's a lot more fizzy. What makes the pop fizzy?
Carbonation.
Carbonation. What kind of gas are they putting into the soda?
I don't want to say the obvious, but carbon.
Carbon dioxide.
Carbon dioxide.
Yes, they're pumping. They mix this all up in big batches at the factory, and then they actually inject it with the gas to make it fizzy, and that's the bubbles you get.
Okay.
And we really need lots of bubbles today to do this experiment. So let's take our bottles and move it to the ground, and we'll get ready to put the Mentos in there down once we get to the ground. So as I mentioned, we're going to move the soda to the ground, and because this is going to get messy. I don't advise doing this in Mom's kitchen because it could get a little sticky, okay?
Aww.
So it's on the ground. We're going to take the lids off now, each of them. Just go slowly because they might have shook up a little bit, so they're going to be quite carbonated. And let that fizz off.
That one sounds very fizzy. I'm gonna guess that one's gonna go higher.
Oh, you think so? Now you're changing your prediction.
Well,
That's okay. I'll let you change it.
okay.
Okay, now as I mentioned, we've put these Mentos. There's nothing special. I just put them in this container because it allows me to drop it in the bottle faster
Okay.
and to get out of the way. So you want to drop them all in there, and I'm going to count to 3, and then I want you to let it go. You ready?
Yeah.
So get close. We need one more volunteer here. 1, 2, 3. Oh. Mine fell out. So it worked very well. And you were right. I think the Diet Pepsi went higher.
And wider. And I see that we didn't even hit all the Mentos in the box.
Oh no, I couldn't get them all in. It slipped in the Diet Coke. It went up my sleeve from the Diet Pepsi.
Well, so we've only got this much left in the Diet Pepsi. How much you got?
So you can see how much.
Lots left in the Diet Coke.
It's still fizzing. So how does this happen? What happens? There's a lot of theories about it. I'm not 100% sure. But basically, I'm told that the Mentos has little pits in it, nucleation sites where that carbon dioxide gas adheres to, and it's fizzing so much it has nowhere to go, so it has to go out of the bottle and up my sleeve.
Fantastic.
So that was a fun one. Too bad we didn't have a better budget. We could have lined up the whole parking lot with Diet Coke.
Do you know, I actually never, I know I've seen this experiment dozens of times and it never occurred to me to get out of the way fast.
Oh, I said you have to go fast.
I'm
So yeah.
well done.
So that's a ton of fun. Watch for soda on sale, and you can do tons of experiments.
Awesome.
Okay, so welcome back. We have another fun experiment to do here. So we'll put our goggles on. For this experiment, you're going to need just any plate you have around home, a votive candle, a clear jar or a glass will work great.
Okay.
Some water, and I like to add food coloring because it gives you that really nice visual, so you can see what's happening in the experiment really well. So I have about 100 milliliters of water. It doesn't have to be exact. For this one, that's not going to make much difference, exact measurements. So go ahead, just put it in here and dye it up nice and dark for me, please.
Okay. The whole
thing, yeah. And a few drops. Make it nice and dark so we can see the blue water. Because something's going to happen in this experiment.
Good enough?
Oh, that looks really good. Yes, nice and dark. Fabulous. Great. Now what I want you to do is just pour that water onto your plate now, please. So you can see how, oh, that looks very nice with the yellow candle there. It reflects, great. So normally I would just use matches, but it's a little windy out here, so we're gonna try to get this candle going with the barbecue lighter.
Oh, you got it.
Oh, we'll try again here. And what we need to do is I want you to actually put this jar over the candle before it burns out.
Okay.
And watch very carefully now. I want you to look down here.
Oh, look at that.
What happened? Can you explain it to everybody? What's going on here?
Well, I don't know exactly what happened.
Well, what visually happened? What did you see happen?
The water got sucked up into the glass up around the candle, almost to the top of the candle.
Yes, I hope you've seen before you put the glass on there, the water was not very deep at all. Very shallow, just along the lip of the glass.
Yep.
And once you put that jar over top of the candle, it's created, some pressure. We have an area of low pressure in there now. So we actually have to equalize it out. So what happened, you might have seen a few bubbles actually forming along the bottom there.
Okay.
It was creating that, and it was sucking that water in there to equalize it.
Is this,
It's
if
safe.
I lift it?
It'll be fine. No, it's not hot at all because it was only burning for a few seconds.
It's, there's a suction.
You can feel that pressure, that vacuum that was created in there.
Woo! Yeah.
So that's kind of a fun experiment to show you how
Cool.
you can equalize that pressure.
Super easy to do at home.
Super easy, fun. Again, you're using a flame, so I want you to make sure you
Ask mom and dad.
Exactly, great. So that was a really fun experiment. Another one I think that we should do today, an old standby elephant
I take that?
toothpaste.
Oh, you
Oh,
got
I was
it.
just going over here.
Elephant toothpaste
Move this out of the way.
for your pet elephant.
Well, yes, I have that elephant and I need to brush his teeth. You should brush your teeth 3 times a day. So we need to make a big batch today. So I'm going to give you graduated cylinder, one for each of us. And we're going to actually compare. I was lucky enough to get some chemical to do elephant toothpaste. And I want to see, everyone says this does a better job than if you just use household stuff.
Okay.
So I want to compare. So I'm going to let you just use a household catalyst here. And you're going to mix it.
Oh, it was fresh. It popped.
And that's really key. You need to have fresh ingredients for this experiment.
Okay.
Ingredients or materials, because if your catalyst is old, it's not going to work. If your hydrogen peroxide is old, it's not going to work.
We tried this before and it didn't work. And then when we looked at the expiry date on the yeast, it was 2010.
Exactly. So that's was 99% of the problem, I think. So you need
Okay.
some soap.
Okay.
You have your catalyst, something to measure it with, a graduated cylinder to measure some water, and our hydrogen peroxide. You can you can buy stuff. I advise going to a beauty store to buy your hydrogen peroxide. It is a little stronger than what you would find at the drugstore, because you're only getting 3 or 5%, I believe, at the drugstore. Here you can get a little stronger. If you're doing this at home, safety first. You need your goggles. If you are, gloves. I've done this a lot of times, but you might want to wear rubber gloves.
Okay.
And then again, this is going to make a mess. So you want to do it in an area that you can get messy.
Okay.
And with the
Outside.
outside is great, like we are today. And like if you're using the actual chemical, it will turn things black or brown. So this is going to stain as well. So you have to be careful. Could you grab the food coloring beside you there? We need food coloring. I want you to do yours red and I'm going to do mine blue so we can see the difference to see who actually does go higher. So when you're measuring water, it is very important to do it at eye level because water does not form a straight line on your graduated cylinder. It actually has, a little dip in it, a meniscus. So in that middle, we have to make sure we get it, that measurement.
From the bottom of
The bottom, not the top. So I like to get down, eye level right here.
50?
50. We're going to go 50.
Okay. My turn?
There you are. And I'm just going to continue to make my saturated solution in my beaker here.
Ooh. I overshot. All right. Let's move this out of the way.
So you can see mine has all dissolved that time, so I need a little more. I need to keep going and adding a scoop. You don't want to add too much at a time.
Oh, whoops.
Oh, you should pour it in your beaker here. You'll be able to stir it much better.
I should probably be careful at how I pour it too, hey?
Well, we don't want to slop too much on spill it onto ourselves. Now I just like to if I had another stirring stick, I would stir it, but I'm just doing a swirl of my liquid here.
So how do you know when it's saturated?
You're not going to be able to dissolve any more of your powder into that water.
Oh, I might be able to get some more in there though.
You're actually going to see a little bit in the bottom of your cup. It cannot take any more of that powder into the solution.
Okay. I think I'm there.
Oh yeah.
It's kind of sludgy, but it's still pourable. I'll call it a liquid.
Yeah, you want to be able to still pour it.
Okay. Cool.
And I'm almost there. It's not dissolving.
This is actually pretty good. Still more, hey?
Well, I think we'll do another one here.
Well, I feel like I should put more in mine now.
Oh no, make sure you get it off the sides there. You got a lot.
Yeah. All right.
Okay, there. See, it's not coming out anymore. It's still a little bit in the bottom, so we'll just put that to the side. Now, I want you to take your peroxide.
Okay.
We are going to go 150 milliliters of peroxide.
Okay, do I go first?
Oh, no, you're fine.
Let's turn this so I can see it. Where's 150? Right there, okay. Unfortunately. Ooh, and stop.
Thank you.
I did move it.
Perfect. Now, it's really hard to see toothpaste, so I think we should color it. Like I said, how about you do red and I'll do blue?
Into
the peroxide, a few drops. Let's make it nice and dark. And then just a little swirl to...
It's just really pretty.
I like mine nice and colorful. Now I know this is real scientific, a few squirts of dish soap. How about 5 milliliters? I say
Oh my!
3 nice squirts.
1, 2. Well, I got it on the side. Is that going to be?
It'll be just fine.
Okay. Swirl it around, yeah?
Yeah, no, well, we don't want very many bubbles. You could give it a little swirl, but I don't want you to make it all foamy and bubbly right now.
Okay.
Now, on the count of 3, we're going to put our catalyst into here.
Yeah, okay.
Ready? 1, 2, 3. Well, I say yours worked way better. Now look, this I always say is a 2-for-1 reaction. Put your hand close to here.
To yours or mine?
Both, or either. What do you feel anything?
Oh yeah, it's hot.
It's an exothermic reaction happening. It gets very hot. It's releasing heat.
Can I touch it?
Yeah, it's not going to, it won't hurt you, but I advise you wash your hands immediately after because there is peroxide in there, which it'll dry your skin out. And but yeah, it's very foamy and kind of slippery. This will stain your hands because it has iodine in it.
Do you know, mine started out bigger, but yours is actually a bigger reaction.
It's growing more and more. Well, the soap in there allows those bubbles, to form. The oxygen is releasing, making more and more bubbles. So, yeah, it's kind of fun. So, you know what? Sometimes fancy chemicals aren't necessarily better than just buying the stuff in from the household. Look at the great reaction you had. I think it's just as good.
I'm going to touch it.
Like I said, you can touch it. Just make sure you wash your hands afterwards. Do not ingest this. Looks pretty, but it is not edible in any way.
It's soap.
It's soap and poison, yes, for sure.
Cool.
So now we'll put this in containers and sell it to everybody who has an elephant. They can brush their teeth tonight.
It's the foam is actually it's quite warm.
Yes, yeah, it's that heat you're getting from the catalyst reacting with that hydrogen peroxide.
And I see the staining you're talking about.
Exactly, because there's potassium iodide in here. Iodine, which if you've ever put iodine on a cut, it turns it nice and brown, right?
Kind of wanting it off now, so.
So we'll wash our hands. Good, good, good. So that one's done. Great
Cool.
job.
Well done.
Well, we're back and we have kind of a fun experiment. Now, Praxis, I don't know, you know, a lot of people don't know this, but we have some great hands-on learning kits. We lend them to educators, homeschoolers, summer camps. Tons of people sign out our kits. There's generally no charge for the use of these kits. And in these, we have these really awesome Aquapod rockets. And I'm going to show you those in a few minutes. But if you don't have that or you can't sign out our kit, which, by the way, educators fits very well with the air and aerodynamics unit in grade 6. There's tons of things in there, rocketry, airplanes, you name it. Great stuff.
Yep.
So if you don't have that, here's something you can do at home. Now, it might be a little bit difficult for you to find. I'm going to date myself a little bit.
What are those?
Do you know what those are there? I know you're a little younger than I am.
Film canisters.
Film canisters. That used to be how we get film. There are a few places in town that apparently still develop film. You can call them and they might give you those. You can order them online. You could use a little Tupperware container as well. So you need those, some water. Now I have these very interesting little plastic tubes. This is just so I can aim my rocket where I want to shoot it. Please don't shoot it at people or pets or break windows. Be careful, right? Be responsible.
There's always a caveat.
Yes, and I like to use these antacid tablets. You can buy them at any grocery store or pharmacy. They work really well. Or you can buy actual fizzing type tablets. These are special, a little more expensive. It's up to you. They
Okay.
both do the same thing. So basically, you're going to take your film canister, and I've already measured out some water here. Fill your film canister about 3/4 full.
Yeah, there's good.
Okay, and I'll fill mine. Just set that to the side. You want one of these antacid tablets. Please don't put it in yet because the reaction is going to occur very quickly because basically these have sodium bicarbonate in it, and we all know what happens when you add that to water. It's going to start fizzing really quick. So get your tube, set it up, because what we're gonna do is we're gonna add the tablet into the bottle and this into there, and then we're gonna aim it and shoot it. So are you ready on the count of 3?
Yes.
1, 2, 3. And then you just, well, it's not gonna be that quick.
Where are we
But
shooting this?
now, oh, well.
I knew it was happening, but
And it kind of catches you off guard because it's this big poof. You know, it doesn't look that exciting, but I always think it's kind of fun. It just blew the top off. Like I said, make sure you're pointed away from anyone and everyone so no one gets hurt.
Sorry about that.
And it built up. What happened was all that fizzing, you know, the chemical reaction built up all that pressure. The air had nowhere to go. So what happens? The top pops off, and that creates our rocket. So tons of fun. That's kind of a fun one. Now, I think we have time maybe to do an exploding bag. This is a fun activity to do in the summer. So we're gonna use a lot of the same materials. I'll just use this, move this out of the way.
You're gonna
We
make a
need-
mess, aren't you?
Oh, we're gonna make a mess. Again, we need baking soda, vinegar. We have a container of vinegar, a measuring spoon to just scoop out the baking soda.
Okay.
We need some tissue. Oh dear, and there's my measuring spoon, just throwing things around here. And some tissue.
What's the tissue for?
Oh, you'll see in a second. And a couple just zipper type baggies. I recommend the zipper type ones. You can just contain the mess a lot better. So I want you to take a piece of tissue and separate it apart. You want just a single layer of tissue. I'm really quick. Here, I'll share with you. You can save that for later.
Okay, thank you.
So what you want to do is we're just going to fold this, rip it in half. Let's rip it in half because we have very small baggies today.
Oh my goodness. There's not like...
There's no exact science to this. We're just going to have tons of fun.
Oh, fired. Okay, now what?
Lay it down, fold it in half.
With both pieces?
Oh, no, I'll just take one. There you go. Just one piece.
How'd you get yours to rip so nice?
Well, I've done this lots and lots of times. And what you want to do is we're going to add 2 scoops of baking soda into our Kleenex.
Right in the middle? Yep.
And we're just going to fold it over and make a nice little package with it. Just fold it up. We're making a little present of baking soda here. Just save that like that.
Okay.
Excellent.
What did you do here?
So just fold the corners up, make a little present out of it. Just tuck it all in so it doesn't leak out. And I just turn it over to seal the sides.
Okay.
Now there's no exact science to this either. You can take your baggie, we're gonna open it up, and we're gonna pour some vinegar in there. Because what happens when you add vinegar to baking soda?
Fizzes.
Now if you wanted, you could add food coloring, but oh goodness, that gets awfully messy.
On my white lab coat, I have a bad feeling about this.
Oh no, so I'm not gonna add food coloring today.
Got some traffic.
It's busy today.
Is that enough, do you think?
That's perfect. About a quarter of the bag full. Now, you're going to add your little present of baking soda. The reason why I wrap the baking soda in the tissue first
Tell me more.
was because it'll take a little bit longer for that reaction to occur. The
Gives us
vinegar,
time to close
yeah,
it.
close it up and set it aside. So you're going to take this, and we're going to act fairly quickly. We're going to take, yeah, you might want to zip it up halfway or to get ready. So you're going to take your package of baking soda, drop it in, and seal the container up.
Okay, so then
on the count of 3.
Okay, and then where are we gonna put the bag?
We're just going to leave the bags right here. You'll be fine.
We're not gonna hold
Oh,
it.
don't be worried. No, we'll be great. You ready? Oh, mine broke. So zip it up. Oh, and I'm going to move out of the way.
Well,
Okay. So experiment a little bit. And I scared you a little bit.
I was kind of expecting like shrapnel. I don't know.
Sometimes it happens. Experiment a little bit and see what proportions you need for a bigger explosion, right? So you can do it. You can have grand explosions, trust me. And like I said, add a little food coloring if you want. You can make quite a mess in this. Great activity for the summer.
For outside.
For outside. As we were saying, Praxis has a lot of really exciting hands-on learning kits that we lend to educators, summer camps, and this is one of the rockets out of the aerodynamics kit. You can attest to this. We've tested many rockets, and this is by far our favorite one. They're a little difficult to get. We tried buying one the other day, and they're sold out everywhere.
Yeah,
So
they're popular.
call Praxis early and book it is the best advice I can give you if you want to borrow our kits. So basically, this is a really easy one. Now, we would normally do it on the ground, but because we're filming today, we've put it up on a higher surface. We've taped it down. So it is going to be a little tricky getting our water bottle onto the valve here.
Yeah.
Because it does leak a little bit. So you're going to just have to be rather quick at it.
Oh gosh.
And get it, there's just no good way to do it. And be careful of your O-ring. You don't want to push it too hard. Just gently over.
And make sure
You want to
that
get right to the...
Well, I've got to push it down to get the. There we go.
There.
Yep, I think that's a good one.
Okay. I'm going to...
Ease it off a bit.
I think I want mine right about there. Let's do 10 pumps. You're going to feel the resistance and the pressure. We need to fill this bottle with pressure so we can get it to launch nice and high.
Okay.
So are we good?
Oh yes, there we go.
I can feel it getting harder. Okay, there's 10.
10?
I think I want to go a couple more. 11. Okay.
12, I think that's it, yep.
Okay, so let's gently take your string and go back here, else we'll have another shower this fine and warm day.
Okay, count it out.
Count down from 3,
3,
2,
1.
much better.
I think mine went higher.
I think you won.
Awesome. Yeah, so these can be booked through Praxis.
Anytime, and most of the resources through Praxis are of no charge.
Oh, yeah.
So it's even
Free.
a better deal. So book early and use these. We love just having our resources out in the community and everyone using them. If you want to book them, call Praxis at
403-527-5365.
or we're on the web at
www.praxismh.ca.
and thanks for joining us today. I had tons of fun.
Okay, bye.
Bye-bye.